Let's solve a bunch of examples of trig equations, starting with that one on the top. The very first thing that we want to do as we're working through these, I want to isolate theta. So I'm really going to be isolating the sine of theta to start. So I want to subtract a 1 from both sides, and then I've got 2 times the sine of theta is equal to a -1. I've almost got that sine theta isolated. I'm going to divide both sides by 2, and I've got the sine of theta equals -1/2. So now I just want to know what theta, what angle gives me a sine value of -1/2. Well, my sine values are the y's on my unit circle. I know that those values, when I've got a 1/2, is going to come from a 30, 60, 90 triangle. So you're going to get this memorized, radical 3 over 2. So I can really easily recognize that this has got to be either pi sixths or a pi thirds. As I look around my unit circle, I see that I've got a -1/2 here on the 7 pi sixths. Y is negative in that third quadrant, and I've got a -1/2 here in the fourth quadrant. So those angles that I'm looking for are the 7 pi sixths and the 11 pi sixths. Now this is in one rotation of the unit circle, so for starters, I can say that my solution on the interval 0 to 2 pi, one revolution, I've got theta is equal to 7 pi sixths and 11 pi sixths. Now I also want all solutions or my general solution. So my general solution is going to have infinitely many answers, and that's because I can take either of these landing places, either of these angles, and travel another full rotation, another 2 pi, to land on the same place and to land again where that y value is a -1/2. I can do that twice. I can do 2 pi 3 times. I can do 2 pi a negative amount. So I can take theta is equal to, there's going to be 2 lines here. If I take that 7 pi sixths, I can add multiples of 2 pi, either going forwards or going backwards. So plus 2 pi times n. Your teacher might use k, either one is great. I can do the same thing, I know that's a mess over there, but I can do the same thing with my 11 pi sixths. I can travel again another full rotation, another 2 pi. I can travel 2 pi twice or 3 times or 5 times, and I can also travel that negative. So I can take that 11 pi sixths as my starting place, and I can add on multiples of 2 pi. This is 2 pi n. N is an element of the integers, that's a z, and those integers include 0, 1, 2, 3, and so on, but also -1, 2, and 3, and so on. Here comes our next example. In this next one, I'm again solving for theta, so I want to go ahead and isolate that cosine squared of theta to start. I'm going to add the 3 to both sides, so plus 3 plus 3. I get 4 cosine squared theta is equal to 3. Again, to isolate that cosine, I'm going to divide by 4. So divided by 4, divided by 4, cosine squared theta is equal to 3/4, but I need to take a square root on both sides to get the cosine. So square root, I get that the cosine of theta is equal to get a square root, it could have been either positive or negative. So plus or minus, that's going to be the square root of 3 over the square root of 4. And I can simplify that to plus or minus radical 3 over 2. Now my cosine values are my x values. So as I'm looking for x values of plus or minus radical 3 over 2, I know that I'm narrowing it down here to either pi sixths or pi thirds. Let's go ahead and find those as we work our way around the unit circle. So either positive or negative. I've got one here at pi sixths. Again, just looking at those x values, I've got one over here at 5 pi sixths. I've got another one there at 7 pi sixths. And then finally, in that one rotation of the unit circle, I have another x value of radical 3 over 2 there at 11 pi sixths. So each of these gives me a solution in one rotation of that unit circle. I'm going to go ahead and draw them in here, and there's one more right there. So on 0 to 2 pi, my solutions, there are 4 of them. So those solutions are pi sixths, 5 pi sixths, 7 pi sixths, and 11 pi sixths. Now I also want to get to the solution in general. Now I could definitely take each of these and add a plus 2 pi n to each of them, but I notice that they've got this really nice relationship. I can take pairs of these, and I notice that they are 180 degrees, half of a rotation apart. So from pi sixths, if I add pi or subtract pi, I can get to 7 pi sixths. I can get to that other location. So as I'm writing out my solution here in general, so in general, theta is equal to, I'm going to take that pi sixths and I'm going to add multiples of pi this time. So plus pi n, and that takes care of my pi sixths and it takes care of my 7 pi sixths. Now to take care of the other two, they are right here. I can go ahead and start with 5 pi sixths and add or subtract multiples of pi to get to that other landing place at 11 pi sixths. This is going to get me to all of those infinitely many solutions. So that second group starts with a 5 pi sixths, and it's going to add multiples of pi n. Now in this next one, I'm again solving for theta, but this time I'm going to use factoring. I notice that I've got this tan theta in common. Because I'm using factoring here, I want to make sure that I've got 0 on one side, and I already do. So I'm ready to divide out or factor out that common tangent. So I'm going to divide both terms here by tangent. So on the outside of parentheses, I end up with a tan theta. And then inside the parentheses, I've got tan divided by tan, which is 1, plus 2 secant times tangent divided by tangent. I can cancel those tangents, and I end up with plus 2 secant theta equals 0. Now this product is equal to 0. So that means that tan times my quantity in parentheses is equal to 0, I actually get two cases from this. So I can say that either the tan of theta is equal to 0, or 1 plus 2 secant theta is equal to 0. Let's go ahead and start with the tangent of theta equaling 0. Now the tan of theta is y over x. So in order to get a tangent equal to 0, I really need that y value to equal 0. So I'm going to go around my unit circle and figure out where y is equal to 0. So it's equal to 0 here, and my y value is equal to 0 there at pi as well. That gives me two of my solutions on one rotation of that unit circle, or on 0 to 2 pi. So on 0 to 2 pi, theta is equal to 0 or pi. We'll do the general solution in just a second, but let's go ahead and take a look at our other case. In our other case, I have that 1 plus 2 secant theta is equal to 0. I'm going to take this and solve it for my secant. So I want to get 1 on the other side. So I get 2 secant theta is equal to a negative 1, and then divide both sides by 2. I get that the secant of theta is equal to negative 1 divided by 2. Let's go ahead and put this down here. I'm going to reciprocate both sides. Just flip both sides upside down. I know that the reciprocal of secant is cosine, so I can write that as cosine theta is equal to the reciprocal of 1 over 2 is 2 over 1. So the cosine of theta is negative 2 over 1. Now, hopefully a big red flag flashes right in front of your eyes here, because this isn't possible. My cosine values, those are fractions that I get off of my unit circle. My cosine value can only be between -1 and +1, so the cosine of theta cannot equal -2. So what I've got right here are all of the solutions in one rotation of the unit circle. Let's get to our general solution as well. So we have solutions at 0 and at pi. I find that drawing these out is super helpful, even just a quick little sketch, because now I see this relationship. I don't need to take both angles separately and add full rotations of 2 pi. Instead, I can start with 0 and I can add multiples of pi. I can add 2 of those. I can go backwards. I just need 0 plus pi n. So my general solution, and I'm going to simplify it even more than that. My general solution, I could write 0 plus pi n, but that 0 is really not needed. So I can go ahead and get rid of the 0, and that general solution is just pi n. I'm going to use factoring again for this example, but that means that I need a 0 right here. Let's go ahead and add a 1 to both sides so that we've got 0 on one side. This gives me 2 times sine squared of theta plus 3 sine theta plus 1 is equal to 0. Now this looks so much like a trinomial, right? It could have been 2x squared plus 3x plus 1. So I'm going to think of it that way, and I'm going to factor it into two binomials. Those first two values need to multiply to be our 2 sine squared. So to get that, I'm going to put in a 2 sine theta times a sine theta. So I've got that first one, that first product guaranteed. And then the last group needs to multiply to be a 1. So this last one times that last one needs to multiply to be a positive 1. There's only one way that can happen, and that would be a 1 times a 1. So what we've done is to create a product, and it's the easiest product possible because I've got something times something equals 0. So I can take both of those somethings, 2 sine theta plus 1 equals 0, and the other one, sine theta plus 1 equals 0, and find all of my solutions from these. So I'm just solving these equations now separately. Let's start by subtracting that 1 from both sides. I'm going to work on the equation on the left. And then I want to divide both sides by 2. I'm isolating that sine theta. So I get that sine theta is equal to -1/2. My sine values are my y values. So I'm going to go over to my unit circle, but I'm also thinking that that belongs to 30, 60, 90 triangles. I'll bet these are multiples of pi sixths. We've seen these before. So over here to our unit circle, I'm picking up a -1/2, and I've got one for my y value there at 7 pi sixths, and it shows up again there at 11 pi sixths. So I get two possible answers in one rotation, and those are 7 pi sixths and 11 pi sixths. Now let's look at our other factor. So our other factor was sine theta plus 1 equals 0. If I subtract that 1, I get that sine theta is equal to -1. Now again, my sine values are my y values. So I need to be at -1 for y, and -1 for y shows up right here at 3 pi halves. So adding to my list, I also get 3 pi halves. So this is on 0 to 2 pi. I also want that general solution. I'm going to do a quick sketch to see if I've got any relationships. 7 pi sixths, I've got 11 pi sixths, and I've got 3 pi halves. I don't see any relationships between these three, so I'm going to go ahead and write this as a 3-part solution. So my general solution is going to be a 3-part solution, and that 3-part solution includes 7 pi sixths plus 2 pi n, and then 11 pi sixths plus 2 pi n. You could definitely write these in order. And then I had that 3 pi halves plus 2 pi n. In this last example, I just have a single trig value, so I don't need factoring this time, but I do want to start by isolating that sine. Notice I've got a multiple angle inside of there. As I'm isolating that sine, I'm going to divide both sides by 2, and I get that the sine squared of 2 theta is equal to 1 divided by 2. Next, I'm going to take a square root on both sides, square root, and then you're going to watch this next video. You've got this.